Hello. This week we're going to look at some trig equations and some complex numbers. This first example, we want to know which quadrant cosine is positive in and tangent negative. So this is where the cast rule comes into play. Cast tells us where things are positive. So cosine is positive in this one because it's cosine, and this one because all of them are positive. And tangent is negative in this one and in this one. So we know that this quadrant here is the one that we're looking at. This is also known as quadrant 4. Now, if we label the quadrants, quadrant 1, 2, 3, and 4. Now, you don't have to use Roman numerals. You can just use regular numbers if you want, but that's just the way we name them. Now, the next one, we want sine theta negative and cos theta equals to 0.75. So, if we write out cast again, sine is positive in an A and S, so negative means we're either here or here. Now, for cos theta equals 0.75, we can find theta by doing cos inverse of 0.75, which gives us a theta of 41.4 degrees. Now, 41.4 degrees would be here, but that's not the one we want. We also know that cosine was positive in this case, so it's positive in A and C. So if we do 360 minus the 41.4, we get 318.6 degrees for our answer. Here, let's solve 2 sine x equals 1. So this would be sine x equals a half. Now, this is a positive number, so sine is positive in these two quadrants, C, A, S, T. It's positive in A and S. So x equals sine inverse of a half, which is 30 degrees. So if this is 30 degrees, then this is also 30 degrees, so we do 180 minus 30 degrees to get 150 degrees. So we have two answers, 30 degrees and 150 degrees. Here, 5 cos x plus 4 equals 0. So rearrange to isolate cos x. So subtract 4, divide by 5. So x equals cos inverse of negative 4 over 5. We end up with 143.1 for our first x. Now here we had cosine was a negative. So again, looking at CAST, cosine is positive in the first two. It's negative in these two. So we're looking over here. Our first answer is 143. Our second answer will be this one. So 360 minus 143.1 equals 216.9 degrees. So those are our two answers. Now let's look at a tan one. Here we have 3 tan x equal to 5, divide by 3. It's 5/3. Again, this is positive. So CAST, tan is positive in these two. Now x equals tan inverse of 5/3. So your first one will be 59.0 degrees. And then if we do 59.0 plus 180, we get 239 degrees for our second one. This time we have sine squared. Start off the same idea. So isolate sine squared. So plus 1, divide by 4. So we get sine squared x equals 1/4. And then to get rid of a square, we square root. But it's going to be plus or minus the square root. So we're going to actually have to break this up into two questions. Sine x equals positive a half, and sine x equals negative a half. So each one of those is going to give two answers, so we're going to have a total of 4 answers. So x equals sine inverse of a half gives us 30 degrees. Now this was a positive half, so we're looking at these two quadrants. So 180 minus 30 equals 150 degrees. Over here, it's negative a half, so we're actually looking in these two quadrants. X equals sine inverse of negative a half, which which is negative 30 degrees. But we need to correct that by adding 360. So we get 330 degrees. The other one down here, if we do 180 minus negative 30, or think of it as 180 plus 30, we get 210 degrees. So we have four answers. We have 30 degrees, 150 degrees, 210 degrees, and 330 degrees. So again, we had a positive here, so it's positive in the A and the S quadrant. We have a negative here, it's negative in the C and the T quadrant. Remember, CAS tells us where it's positive and where it's negative. Right, let's look at another example of tan. Isolate tan first, so tan 2x equals 3/5. Now, we have 3/5, means we're in these two quadrants. Those are the two that tan are positive in. So 2x equals tan inverse of 3/5, which is 31.0 degrees. Now, before dealing with the 2, okay, we're going to look at this 31. So we know this is 31. Add 180, so 31 plus 180, so 211 degrees. Now, we take each of those and divide them by the 2. So we had 2x equals 31, so x equals 15.5 degrees. And we take the 211, divide it, so we get 105.5 degrees, and that's two of our answers. But that's not all our answers. We know from the graphing unit this 2 will give us a period of 2 pi over 2, or 360 degrees over 2, which is 180 degrees. So if we add our period to each of these, so 195.5, and 285.5, we get our other answers. And again, those are all the answers from 0 to 360. You could add the period or subtract the period as many times as you'd like, and you'd always find an answer. But we only care about the answers between 0 and 360. So the answers to this question are 15.5, 105.5, 195.5, and 285.5. All right, another example. This time you'll notice we have that 2x again, so we are going to double them. So instead of 2 answers, it'll be 4. But we also have a phase shift here of positive 45 degrees, 90 over 2. So we are going to have 4 answers, but they've been shifted. So again, let's start by solving for cosine. So we get 3/4. So 2x minus 90 equals cos inverse of 3/4. 2x minus 90 equals, that's 41.4 degrees. But before we get to the 2x minus 90, we're going to look at this, and we know 3/4. So 41.4 is here. We're looking at cosine, so the other one's going to be here. So we're going to do 360 minus the 41.4 to get 318.6. Now we set 2x minus 90 each to equal those. And solve for x. So add 90, divide by 2. This will give us 65.7 degrees and 204.3 degrees. But those are only 2 answers. We need to find the others. Again, the 2 will tell us the period is 180 degrees again. 360 divided by 2. So if we add the period, to each of those, you'll get your next answers. But if we actually add 180, we're going to get over 360. So this time we're actually going to subtract. You can always add or subtract, but you want to stay within 360. So we're going to get 245.7, and we're going to get 24.3. So our four answers are 24.3 degrees, 65.7 degrees, 204.3 degrees, and 245.7 degrees. All right, let's do some complex numbers. So the first one, we have 5 minus 8j, and we want to write it in polar form. I always like to graph these out. So we go 5 over to the right, and then we go down 8 to give us this. So we are r theta. So r, we can just use Pythagorean theorem. So 5 squared plus negative 8 squared, all square rooted. And this will be approximately 9.43. Theta is always going to be tan inverse. So in this case, tan inverse of negative 8 over 5, which is negative 58.0 degrees. But we don't like the negatives, so we're going to add 360 degrees. So basically what that says is we've gone back negative 58, but then if we add a full circle, we're back to the same spot. So we end up with 302.0 degrees. Putting that all together, we get 9.43 at an angle of 302.0 degrees. This time, we're starting in polar form, and we want to go to rectangular form. Now, you could just remember x equals r cos theta and y equals r sine theta, or just remember the trig form. So if we put this into trig form, we get 20 cos 300 plus j sine 300. Simplify that out, you get 10 minus 17.3j. This example, we want to go to exponential form. But we can start with the same idea, graph it out. We know we're down here somewhere. To the left 12 and down negative 17. From there, we can start the same way we kind of started with polar. We want our r, so negative 12 squared plus negative 17 squared, which is about 20.8. Theta will be tan inverse of negative 17 over negative 12, which is 54.8 degrees, but 54.8 is up here, so we're going to have to add 180 to correct it, just using cast rule. So we get 234.8 degrees. But that is not what we want for exponential. We need to put this into rads, or radians. So we end up with 4.098 rad. Now, whether you use your calculator or just times by pi over 180, just remember, exponential form has to be in radians. So 20.8 e to our angle j. One last example. This time we have it in exponential form and we want it in rectangular. We can make use of the trig form again. Let's put these in brackets. Probably make less mistakes in your calculator if you have those in brackets. Now, if you're going to do this in your calculator, make sure you're in rads for calculation purposes. We get negative 20 plus 0j, so this is just equal to negative 20.